All right, so here's a video going over the review for the second summative in Unit 2. So the first target on this was solving absolute value equations. So remember, the rule was that the absolute value has to be all by itself, which in number 1 it is, and then you can make two equations. So we always keep what's inside the equation the exact same for both, but then it's what's on the other side, we make one positive, and then we make the other one negative. And then you have two equations that you can go ahead and solve. And you'll take the same steps, you'll just get two different answers. So 24 minus 8, that's 16. If I divide by 4, then for one answer I get x equals 4. Same steps here. If I divide by 4, negative 32 divided by 4, that's negative 8. And then it doesn't matter what order you write your answers in. But you can say x equals 4 and then x equals negative 8. Okay. Now in number 2, so here is the absolute value expression. There's a 5 on the outside, so that one we have to get rid of the 5 first. So in this case, I would divide by 5, because that's 5 times the absolute value. So then divide by 5. So then we'll end up with the absolute value of 2x minus 8 equals 6. And now the absolute value part is all by itself, which is good. So now you can make your two equations. So we keep the inside the same for both. Oops. But then the other side, it's one positive, one negative. So 6 and negative 6. And then again, same steps. So 2x equals 14, divide by 2. So we get 7 for one answer. By 2, and we should get 1 for the other answer. Okay, and then again, it doesn't matter what order you write these in, but those are your two. So anything on the outside of an absolute value expression, you have to get rid of that first. All right, the next target was piecewise functions. So as far as evaluating, you have to decide, so right, this g of negative 3, that means plug in negative 3. The problem is, what equation do you plug it into? Well, that's when we look at these rules and we see where negative 3 fits, because this is your x. So that means that we're going to use this top one because negative 3 is less than 3. So this one we use the top equation. So instead of x, we're going to plug in a negative 3 and figure out what our answer is, which would be negative 10. Right? We're just plugging it in. So then for the second one, I have g of 6. That means plug in 6. But when I do that, that's going to be the bottom equation because 6 is bigger than 3. So I have negative 2 times 6 minus 5. So I get negative 17. Okay, and then that's what we're looking for over here. So negative 10, negative 17. Okay, so it's evaluating. As far as piecewise, we did this by making two separate tables. So I have an xy for my top equation, and then I have an xy table for the bottom equation. So we always start with whatever number is in the inequality. So I'm going to start with a 1, and then I want numbers that are less than 1. So like 0, 1, oops, hello. 0 is less than 1, negative 1, negative 2. Okay, and then I'm going to plug those numbers in. So I'll do 3 times 1 minus 2. 3 times 1 is 3, minus 2, that's 1. Then I'll plug in 0. 0 minus 2, that's negative 2. Plug in negative 1, all for this equation. So it's negative 3 minus 2, that's negative 5. Plug in negative 2, that's negative 6 minus 2, that's negative 8. Okay, now that first point we have to decide, is it open or closed? Since from that inequality it was a less than, that means this is an open circle. So I can plot those points. So 1, 1, that's open. 0, negative 2. Every point after that's just regular. Negative 2, negative 8. So here's my first line. Okay, then I'll do the same thing for the second one. So always start with whatever number's in the inequality and then follow the inequality. 2, 3, 4, so on. You could pick more. 4 is pretty good. Okay, now I'm going to plug in 1. So this one already has a negative sign. Then I'll plug in 1 for x. So negative 1 plus 6, that's 5. Negative sign, 2 plus 6, that's negative 2 plus 6, that's 4. And I'll just keep going. And those are my points. Now the first one we decide is open or closed. Since that's an or equal to, this one is closed. So at 1, 5, it's a closed point. And then I have 2, 4, 3, 3, 4, 2. And my line's going that way. Okay, so that's graphing your piecewise. Next target was the transformations. So remember, anything that's on the inside of the symbols, absolute value, parentheses, square root, whatever, that tells you left or right, but do the opposite. Anything outside the symbols tells you you're going to go up or down, just do what it says. And then the A value, anything in front, if it's negative, then you flip. Okay? So let's go based off of that right now. So I'll just tell you on your summative, just like you did on the regular one, on the retake, the parent function will be drawn on your graph. So this one, since I see a squared, this is a quadratic, which is x squared. This will be given to you on your test. Okay, so it looks like this. That's my parent. Okay, transformations now. So the -4, that's inside. Inside tells me left or right. Do the opposite. So this would mean right 4. And then anything on the outside, that would mean down 2. So this graph, we would say right 4, down 2. Okay, so I want to take that graph and I want to move every point right 4, down 2. So it'll end up looking like this. I just moved every point right 4, down 2. That's my final. And then I do domain and range based off of that. So domain is always my x's, so left to right. There's an arrow pointing left and an arrow pointing right. So this is negative infinity to infinity. And the range is the y values. The lowest y value is at -2, and then it goes up forever. So that's my domain and my range. That's from the last test. Okay, next one. This has the square root function. Oops. So this one looks like this. Again, this will be given to you. Okay, the transformations on this one is inside the +2. So inside is left or right. Do the opposite. So this would mean left 2. So I'll move every point left 2. That's my final. Say left 2 for the transformation. So again, domain is your x values. So this one, the first x value is at -2, and then it goes to the right. And the y's, the lowest y value is at 0, and then it goes up. Okay, a little bit more on transformations, just identifying the transformations based off of any function. So this negative sign out front, that would mean that I have a flip, or you can say reflection. The +7 on the inside, that would mean left 7. And then the -8 on the outside, that means down 8. Okay, so then same thing for B. That -4 is on the inside. Inside means left to right. Do the opposite. So this one just means right 4. Okay, so that's your transformations. Last page. So Justin Field solved the following absolute value equation. So here's the equation he was supposed to solve. But he made an error in his work. So circle or highlight the step where he made an error and then explain what he should have done. So when you look at this problem, this means he branched it out right away and he dropped the absolute value symbols. Okay, and then it looks like he combined like terms, like to get the 3 and over here too. And then he subtracted 3 and he got his answers, right? He didn't do any adding or subtracting wrong. But what he did do wrong was kind of in this very first step. He should have added 3 first. So it should have looked like this, where he adds 3 first, and then makes 2 equations. So it should be x plus 6 equals 8, and x plus 6 equals -8. And he did not have that. He did not add the 3 first. So that's what I would say here. He should have added the 3 first. Okay, so it's an error analysis. All right, and then last question, given f of x is a function, write the equation for a transformation of f of x with a reflection over the x-axis, a vertical shrink of 1/2, right 6, and down 13. So when you do this, you want the f of x, and then we might need to fill in some other stuff. So a reflection over the x-axis, that's a flip. That means there is a negative sign out front of your function. Now a vertical shrink, that also is the a value that goes in front. So that would just go right in front of the f. So it's negative, that means a flip. 1/2 means a shrink. Right 6, that goes inside. And we do the opposite. So right 6 would be -6. And then down 13, that goes outside. And we just do what it says. So this would be that function all written out. Okay? All right, let us know when you're ready for a retake.